Welcome.
To the joy of coding.
Hello, and welcome to episode 64 of The Joy of Coding. My name's Mike Conley. There's going to be some good stuff today in The Joy of Coding. We're going to be doing hopefully some Firefox performance analysis of various things. I've got some more work to do on that patch we've been working on for what seems like forever, that make the initial browser be remote patch. I'll have some updates for you on that. And there's some other stuff we can do as well. I've got like a big slog of work. Let's not waste time. Let's get right down to it. So, switching to my screen, and I've got my agenda here. So I say this every time, and so this time's no different. If this is your first time watching, this agenda is available to you. It's probably not useful to just like read this and then I'll flick away and you can't click on stuff. So it's available to you if you go to the additional links section. If you scroll down, if you're watching this on AirMozilla, there's an additional links section with a link to this document and all the links you can click on, and you can follow along with what I'm doing. The other thing is, hang on, did I get that link right? I did. Okay, good. The other thing is that, this document, I might write some stuff into it over time, and it should synchronize periodically. So if I make some changes and they're missing or something, just reload the page. Maybe it'll show up, or bug me in IRC if I need to hit this like automated or background sync button, and it'll just do it. Okay, so there's that I wanted to talk about. Oh, the other thing is, there's an agenda. It's not really much of a plan. It's kind of just an outline of things we could do today, things I kind of want to do today. And so things could go wrong. I might go off trail a little bit. We might not even get to some of these later items. That's okay. We're just going to figure things out as we go. So, what are we doing today? The first thing I want to talk about is this Make Firefox Faster campaign. So I did this a couple of weeks back, before I left for London, I think. And I don't know if it was very successful, but I'm doing it again just in case. Basically what happened is I created a thread on Reddit, which is a website you may have heard of. Here, I'll update the agenda with a link to the thread. Basically, I put this thread out there and I said, hey, I want to make Firefox faster. I've done this before. This is the link to round 1. And I said, give me performance profiles. If you have some performance problems with Firefox, record a performance profile, send it to me, and then I'll analyze it and hope maybe we can figure out what's going wrong, or maybe I can do file a bug for you or anything like that. That was the plan. And it kind of was successful last time. Like a bunch of profiles got posted and I did some analysis. Not as many profiles as I thought. I'm not sure if maybe my instructions are bad, or one thing that was very interesting is that in this round 2, people were saying they didn't have performance problems. The top comment here was, what do you think would be a good way for people that don't have performance problems to help? And a user named Dr. Dichotomist came in and wrote some really great tips on things that they can do. So maybe it's because the people who have performance problems are not in this subreddit. Maybe, or maybe they didn't see this thread. But I was able to find a couple of things I think that I can address in here, or at least we can investigate. And I put links to the comments, direct links to the comments in the agenda. So let's check them out. So the first one is there's this. Here, let me get the context for. View the rest of the comments. Actually, I wanted to. This is what I was linking to. So someone wanted to know if they could profile the startup of Firefox, and that's a great idea. If we can make the startup of Firefox faster, that's great for everyone. Dr. Taconomus pointed out this add-on I'd never heard of before, which is the add-on startup add-on, about startup add-on, and it it dumps out basically it dumps out the first load or the a bunch of information about like when certain things occurred in Firefox, like when the session was restored, when first pane occurred, when the first window was created, that sort of thing. And when was this created? June 24th, and it's probably a pretty simple add-on. I think it's using like the just the get startup, NSI app startup stuff. Oh, it's also doing it in Thunderbird, I guess. It's got like a Thunderbird compatibility layer. But like in About Startup, what it'll do is, yeah, it will. Oh man, it's doing a lot more than I thought it was. Where is it getting its numbers from? Startup data. Where is it getting startup data from? Startup data.jsm. Startup data. The data is coming from a file. Where is this file coming from? Oh my goodness. Startup info. That, see, this is the stuff I thought it was getting. This is what I thought it was doing. It was going to use get startup info, and then it saves it to disk. That's interesting. Dot save. So you can save it to disk. You can load it from disk. So this add-on does a lot more than just sort of expose the NSI app startup um, dictionary or objects. Because if you're in, excuse me, if you're in the browser console, for example, you can do this yourself. You go services dot startup dot get startup info, and you get basically this object with all these properties, like when the session was restored, when the session started to restore, when the profile was selected, when the main process started, right here. When did first paint occur? When did we first start loading a URL or a URI? That sort of thing. And so I guess this stuff's pretty interesting, pretty important. You can get that yourself if you're curious, and that's the sort of information that's being exposed by this add-on. And then, hang on, I just have to. Uh, okay. And so the startup stuff, that's what they're talking about in here. They took a quick look at the extension. It uses the get startup info. And then form null, 6 days ago, I probably should have responded before that, says that the delta between startup crash detection begin and startup crash detection end seems really huge. And they ask if that's something to look at. So I don't know. I don't know. So crash detection, I guess there's this window of time where if a crash occurs within a certain window of time, we consider it a startup crash. And startup crashes are different than normal crashes because a startup crash is one where we suspect that something about Firefox's configuration is causing the problem. And so if we notice several startup crashes in a row, we'll then put Firefox in a much safer configuration so that you can at least like maybe disable some add-ons or something. Um, so it might be expected that the startup crash detection end is, quite a bit further along. Like startup crash detection begins at 276 milliseconds, I guess. And then startup crash detection, or well, it's undefined here, but they all seem to occur within like these. I'm guessing are in milliseconds, so it's like 30 seconds, 31 seconds, and maybe Maybe that's by design. So let's find out when these startup crash detection end bits happen. So I'm gonna check DXR for, yeah, startup crash detection ends gets set here, I guess, or this is where we set up some defines. We map this sort of constant um, to the startup crash detection end property. So let's see where this is being used. Here, we record it here. Startup crash detection end at, so we have this track startup crash end. So something must call this, and let's find out what calls it. What's calling it? Startup crash end. Ah, here. So in the browser glue, we say track startup crash end, but that's when we quit the browser. So we say we're not tracking startup crashes if we're quitting the browser. Okay, so not there. Where else? Oh, here, browser-based content browser. This is interesting. This is in the delayed startup of every window, I guess, and startup crash tracking after delay to catch crashes while restoring tabs. That's interesting. We do this, it looks like, for every window. That might be a bug. It's not that important a bug, but it's like, it doesn't seem to make a whole lot of sense. Maybe it matters because we want the first browser to be visible, but then we could like use the delayed startup inside browser glue. Anyways, there is what looks like a 30-second delay after which we call tracking or track startup crash end. So that delay that is being pointed out here by that user is expected. So let's respond to form null. Hey form null, I looked at this today during my live stream, and then I'm going to give him a link. Give him, her, it, them a link to my live stream. I can use during my live stream. I looked at this today during my live stream. I believe the gap is intentional. It looks like. And let me just double check. Whenever we call track startup crash end, if it's already been called before, what happens? If we've already ended or we're restarting into safe mode, then we just return NSOK. So it's basically a no op if we've called it before. So that's fine. I believe the gap is intentional. It looks like there's a window of time in which we'll consider any browser crashes, startup crashes. That window of time is between process start and around 30 seconds after the first browser window paints. So it's not it's not unexpected for this gap to be so huge. It's around 30 seconds, which is so it's not unusual, which is what we expect. It's around 30 seconds, which is what we expect. Here's the, you did cause me to notice that we request to end startup crash detection for every window that's opened. I think that's a bug, although it's not one that I think has user impact. It's a no-op in the case of a window having a case of subsequent windows. Regardless, I've filed it here. So I'm going to file a new bug. Nope, not activity streams. No. Firefox general. Every window calls start end. What was it? End track startup crash end. Every new window calls track startup crash end 30 seconds after paint. I just noticed this. It looks like in delayed startup, for every window, we queue a timeout, queue a 30-second timeout function to call track startup crash end. Track startup crash end is a no-op after it's called once. We should probably only ever call it after the first window paints. I suspect what we want to do here is as browser glue delayed startup on first window loaded. Move the set timeout over to on first window loaded in NS browser glue.js window loaded. Let's take a look at it. Okay. And in fact, I'm willing to mentor this bug. This is a pretty straightforward bug, and I think I definitely will be willing to mentor it. I'm gonna say, yeah, it's a good first bug. Okay, so that's one. We answered that question for the user form null. Hang on, I just have to link. I filed it here. Gonna post the comment. Bam. Okay, so that one's done. Gonna strike that one out. So what's this one? Mike, keep helping look into this performance bug from the first help make Firefox faster. So this would save my life at my third shift job. Shit. Okay, so I guess I have to get in there. I guess I didn't do a satisfactory job during the first round. Performance degradation in heavy CSS JavaScript interactive text. And oh, Jesse Rowland. Yes, I do remember this from last time. This uBlock content policy is causing sync messages to be sent to the parent, which is blocking the content process. Try it, and it does improve ever so slightly, and more so the performance issue is still completely noticeable. So if, like, definitely the uBlock should load stuff is is causing a lot of IPC traffic here. Like look, here's the content process. These like little turtle icons, you can't really tell that they're turtles because they're not very big. This is like, I don't know if you can see me doing that, but these little icons here, they're turtles. And what they indicate is a sync IPC message. And a sync IPC message causes content to like wait around while the parent gives more information. And if we look up the stack, we can see that uBlock origin is at fault. Um, like we have this uBlock origin add-on, and it's the one causing these sync IPC messages. Again, this one, and over here probably. Also uBlock. Yep, these are all uBlock. So the user is saying that disabling uBlock causes the regression to not be so bad. But then what about the other stuff? So there's also some reflow happening here. Some reflow is occurring. Reflow is occurring because we receive a real mouse event. In like the APZ handler causes a reflow. And over here we're ending a paint. So there's a lot of painting going on. Again, content blocking. Content blocking is killing us here. Over here, what's this? This is some JavaScript. We're inside some page JavaScript on this monitoring Pomeroy website. Some jQuery ends up doing some mallocing. Oh, that's not useful. So I think I need more information from this user. Okay, so here's what I'm gonna do. Take a look. And I had to need info on myself. Holy smokes! Wow. Sorry for not getting back for about a month. Yikes. So nothing else really jumps out from these profiles without when I ignore the uBlock stuff. The uBlock samples are completely dominating your profiles. Would you be willing to gather another one? Oh, he apparently did it in comment 3. Functionally attached performance rows without add-ons. Tickets page. So events page profile. So he did. Oh, holy smokes! Wow, that's huge. So this is just the content process. That's interesting. So this is with what's going on? There's a lot of drawing. We are painting all over the place. We are massively painting. We're painting all the time, it looks like. Why are we painting? There's a timer. A timer is going off. There's this timer that's firing. How often is this timer firing? Looks like it's firing like every 200 milliseconds. There's like this timer that fires. Yeah, that's weird. Timer.jsm. Performance recorder. Performance recorder. Do you have the dev tools open? Oh. Yeah, he's using. Okay. Cleopatra instead. What did Jeremy Weasel? So what's the user report? They log in, performance is decent, beginning manipulating rows, double clicking to open, saving input longer to do this. Longer it takes Firefox to do the same task again. Until it continues until Firefox too slow to get work done. I think I tried this. I downloaded the source and I tried looking at it and it seemed okay. I probably have to be using it for a while. You gathered profiles back in comment 7 with your add-ons disabled, but it looks to me like you are using the built-in DevTools Performance tab. What I need is for you to use the Gecko Profiler add-on with the rest of your add-ons disabled. That way, I think is to gather. What I need is for you to gather a profile by using the Gecko Profiler add-on with the rest of your add-ons disabled. I think, I suspect, based on what you've already posted, that there's some kind of, no, it's too hard for me to hypothesize at this point what's going wrong. I'm so sorry to keep making you get data for us, but really this is the only way we're going to figure out what's going on here. Okay. Okay, so that's responding to Jesse Royland, who commented, it was no guy, responded, still need more data. Bam, done. So that one's done. Format, strike through. That one's done. I'm gonna play a sound.
That's right.
Okay, next. Bug 869176 might be worth looking into. For some reason, this game lags severely while dragging in Firefox, while other browsers, while other browsers seem to have no problem with it. This has been the case for the past 3 years. Yikes. Let's see. So we open this game, we drag any object. So the performance is not amazing. I do see some stuttering, but it's also not the, oh, that's bad. Yeah, what's going on there? That little jump there was bad. Interesting. This was 3 years ago though. Let me also check with release version of Firefox with ETNS disabled. Just so I make sure that I'm getting a better sense of what the user. Oh, that's like flashy and gross too. Like, ugh. Look at that. That's atrocious. I don't get the same behavior with other drag and drop. So it might be an issue with your code. Tell you as it is, but yes, performing off on the Firefox comparison. Here's the SPS profile. We spent a bit of time doing proxy stuff in the JIT, which is a really slow path right now. But the largest chunk I found in the profile is 20% hitting layout through calls to get client bounding rect in the page code and mouse move handlers, which forces reflow to occur on the hot path. Actually looks like the proxy stuff is close to 5%. So that's what Josh found. He thinks we're reflowing a lot. Let's see. Yeah, so we're handling a mouse event, and then on mouse move, we do a redraw. And then, yeah, we're in get bounding client rect a bunch. Flush layout. So how much does layout flush consume this? Get OS metrics. Takes a bunch. What is get OS metrics? So it's getting these rects. Look what it was doing too. It was like painting. It was like painting some kind of background of an operating system as well. I don't know if you saw that, but like here we have this like background being painted. Let's see how this feels in a competing browser. Let's look at Google Chrome. And I'll load this. Oh, that's somewhat smooth. Yeah, it's a bit smoother. Where's Firefox? It's smoother. Well, it's smooth, but not as smooth exactly. Like it's just a bit of jank still. For fun, let's see how this runs inside Servo. Actually, I'm gonna pop open Servo. This might not work at all. We're gonna find out. That's interesting. So pretty smooth, yeah. Hmm. So it's not so bad. Not so bad. And then like in the single process case, that is a bit rougher. It's certainly rougher in the single process case. Although, so what I want to know is how much are we painting? Like, let's I'm gonna turn on paint flashing for a sec. Turn on paint flashing. Paint flashing allows me to figure out whenever like the website's fully repainting itself. And I believe, yeah, paint flash. So now I've got paint flashing turned on. We're flashing, we're repainting the whole thing. That's one thing. So we're repainting the whole thing whenever we move these. Woo! Rainbow mode. We repaint the entire page. Sometimes small sections of it, like little clusters. Okay. And then what about Safari? Let's see how it feels in Safari. Yeah, that's pretty smooth. Okay. Okay, so I'm gonna comment in here. This appears to be quite a bit smoother with E10S enabled, although I think that's shielding that's shielding the overall problem here, which is that the page script is constantly querying for a bounding box after every mouse move, which is causing a layout flush. Uh, which is causing a layout flush. So, to sum, this page is acting inefficiently. Is the page has script which runs inefficiently. 2, competing browser Firefox with E10S enabled seems to run those inefficient scripts more smoothly than non-E10S. 3, competing browsers. I tested Safari and Chrome on OS X 1010, or 1011 I think is what I have. 1010. 1010 seem to run this more smoothly than Firefox with E10S enabled. I think I'm going to move this over to layout to see if anybody over there wants to see what's going on. But before I do that, let's go back to this site and let's use our built-in profiler tool inside here. Okay, stop recording. Okay, so yeah, frame rate went way down right here. What we were doing was what? We were doing restyle calculations, epic recalculations. On a mouse move, we recalculate styles. We're doing style calculations on every mouse move when I pick up a card in the demo. Perhaps there's some caching we could do to improve this. So I'm going to move this over to core layout. Or style? It might be layout. Okay. So commented on that bug, and hey, so I looked and it appears as if the page script is doing a style calculation, is causing Firefox to do style calculations on every mouse move event. It's true that competing browsers seem to handle this better than we do, although it does look as if Firefox with E10S enabled performs better than Firefox with E10S not enabled. So that's good. It's possible that there's some caching we could do here to improve things. I've moved the bug into the layout component for better visibility. Alright. So that is done. I'm gonna quickly run through these threads again, make sure I'm not missing anything. I want to make sure I looked at all of the um, possible profiles. Unfortunately, people didn't really post a lot. So this person's saying, what can we do if we don't have performance profiles? Dr. Combs comes in with some recommendations. Okay. Profiling a startup, I got in here and I answered what was going on. Okay, does image loading? And I said yes, but there's no profile in that bug. I'll just double check that there's no profile in here. Bull 500 reported it, said that many images don't load when tabs are open in the background, or they do load and appears fuzzy pixelated. Mostly happens on 9gag. This Nat Geo article, I was reading it and saw a few pictures, continued reading and tried viewing the remainder of the pictures. Unfortunately, most didn't load until after the initial viewing, or some did load after a very long time waiting. So like in the slideshow here, is a slideshow. Okay, so like it does look like these are being loaded lazily. If I look at the network, gonna trash those requests and then like, yeah, we do a get here. We do a get on that JPEG. What ends up coming down is 108 kilobytes. Here comes this image. Let's see if looks okay. Timings, receiving. And then what else happens in this bug? Does this reproduce on a clean profile? Yes, for on a clean profile as well. Same results as shown the attached screenshots. What are the attached screenshots? So like really crappy decoding. Nat Geo. Just waiting forever, I guess. Back channel. Okay. Post the graphics section. Oh. 2. It does seem to load better with this setting. Oh, great. So when we do a user agent override, oh my goodness. It does load better with this setting. So is it possible that like something is up with your user agent? Or like someone is looking at the Firefox user agent string on these sites and is like doing something bad? Ugh. The UA string change being helpful is kind of worrying. I wonder what if it's actually improving things for you. I wonder what these sites are doing. CC Mike Taylor. Mike Taylor is part of the WebCompat group. And he will rain down fire if people use user agent strings to to do awful things. Alright, so that one I commented on it. SVG rendering might be interesting with Gecko Profiler. D3JS heavy pages really make Firefox slow while Chromium is... What is D3JS? SVG rendering. D3.js? D3.js. So like this stuff. Okay. So like, let's look at some examples. Maybe these are gonna perform poorly. Let's find out. So, bubble chart. Okay, looks alright. What about force directed graph? This one looks interesting. Ooh. Oh, seems to render okay. What about a Voronoi diagram? Looks alright. Collision detection? Okay, here we go. Woo! This runs okay for me. Woo, 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 woo. Okay. Motion chart? Oh, very cool. I remember this TED Talk. Alright. What are we doing? I want to like find a really slow example. Oh, that's not great. This one's a little janky. Maybe we can use this. Let's see what it's like inside Chrome. Oh, that's pretty smooth. Whereas ours is jankier. Okay, so we got something here. And I'm gonna look inside Servo. Maybe this is just where, yeah, no surprise. Servo will not parse that right now. Okay, so we got ourselves a case. Let's take a look. So I'm going to use the Performance tab, record a performance profile. Stop. Okay.
I can't do my work!
Come on now. What's your hold up? Give me the profile. Oh. The dev tools are slowing down. Oh man. This is bad. I think I just horked my browser. Alright. I'm going to give it 5 seconds to become responsive. 2, 3, 4, 5. Force quit. That's what happens when you run nightly software. Maybe what I'll do is I'll use the Gecko profiler instead to gather a profile. Okay. And now that that's gathering, I'm going to close that down. We're going to analyze us a profile. Contents where I care about. we're doing all this drawing. We receive a VSync. There's not all. There's like consto painting occurring. Again. Content is just constantly painting. What are we doing? We're allocating, we're doing texture allocations here. So I'm gonna file a, or I'm gonna comment on this bug actually, because I think this is a really good use case. Alright, I'm gonna file a new bug. I'm gonna put it under graphics, core graphics, because I think this is a graphics performance thing. D3.js demo. Is more janky in Firefox than in competing browsers. Here's the demo. Let me see, maybe it'd be worthwhile to save this. Is the demo all self-contained? Like if I save the page, circle, square. I can feel it like hammering my browser too. So if I like go here, no, that does not load correctly. F it. The resource it's not getting. Anyways, here's the demo. I'll put the URL in the, where there's like an, is usually a field. I'll put in later. Runs pretty janky. There's a bit of jank running this. Definitely not as smooth as other browsers. Where's the performance profile? Oh man, did I throw it out? Shoot, I'll make a new one. DOM. Well, what are we doing? What are we spending most of our time doing again? I thought it was, yeah, malloking. JE malloc. There's some waiting going on. Pickle. Maybe I was wrong. paint frame. Shall paint. Okay. We seem to be spending the vast majority of our time inside NSPress shall paint. So putting this under graphics as a first guess. Here's a profile I gathered. We'll upload the profile. And that's enough. We're gonna put the URL, actually, there's a details a URL. Yeah. Okie dokie. So asked about Android, then he responded, figured it would be the ideal platform to troubleshoot low-powered devices, would make performance bottlenecks more apparent, and have the extra motivation in the sense of battery life. And then I responded to this one. So I think my job here is pretty much done. I've looked at everything that everyone pointed me at. This was not a resounding success. I was kind of hoping to see more of a turnout, more profiles posted. I might want to rethink how this works. I might want to open up the number of. I might want to open up the audience to a greater group of people who can send me profiles. I think Tyler Downer got in touch with me about maybe doing something like that, so I should get back to him. All right, let's move on. We're done this chunk. We're gonna move on to this, which is making this bug. What's a good sound to express my rage?
No!
I've got. So the good news is that this patch got final review from Smog. Like the stuff that I was sort of waiting for a long time on. Smog came back. He gave it a thumbs up, and I landed it on Monday night. And then woke up yesterday and it had bounced, or it had gotten backed out. And the reason it had gotten backed out is because there were test failures. And I thought I had more or less solved those, but I guess I had missed some. And so I came up with a solution. I think I figured out what the problem was. Ooh, hang on a second. Before we continue, TS Paint 1203. What? Not gathering TS Paint numbers. It's not working. Grrr. For some reason, this TS Paint test is not working. Sorry, I didn't mean to be so distracted. But I do have to. Oh, I was reluctant at first to accept the Talos Powers issue, but upon further thought, it was actually quite straightforward and good. Try push seems to indicate that. Well, hold on a second. TS Paint. We'll look at TS Yeah, it's gonna look bad there. But that's okay. TS Paint. What am I doing? I bet you're wondering. This is a completely separate issue. But basically, yeah, that's what I figured. That's what we want. Um, uh, my test, it's all kind of connected to the same bug, which is the making the initial browser be remote by default. And so there were two pieces of fallout. The first piece of fallout was the test failures I was telling you about. The second one was a TS Paint regression. I did an investigation to the TS Paint regression, and it looks like the test is actually measuring the wrong thing. So this bug is fixing that, and I just got an R+, although I did a try push, seems to indicate that my fix doesn't emit, fix breaks the non-ETNS case. It's not emitting. Yeah. Results. Looking. Investigating. So I need to figure that out. I'm hoping to get that sort of figured out today. So that's one thing. The other thing is the other failure. The failure here, these oranges, BM and MN. I'd solved the MN ones a long time ago. I'd made this change to Marionette, which is like part of our like infrastructure, our test framework for automating the browser and making it easier to like write tests, not just for I think it's all sort of associated with the like WebDriver stuff that Selenium uses to run the browser, and like we can now run tests against the browser with it. Anyways, I had made a change to Marionette and made things work, but then this stuff over here was broken, these media tests. I thought I figured it out, so I wrote a patch, and now that's broken the Marionette case, and it didn't fix it for this case. And now I'm just starting to realize that this case, does it run with ETNS enabled? ETNS false. It runs the tests with ETNS disabled. That's interesting. So these tests run with ETNS disabled. This test is failing with ETNS disabled. I wonder if this one would have passed. If I re-trigger it, maybe I'll re-trigger it. Actually, I can just hit the re-trigger button. Oh, I need to be logged in. Don't want you looking at my passwords. I know they're all hidden, but then you can get hints on their length. Maybe you can like use statistical analysis on how fast. No, never mind. But I'm just paranoid. Okay, let's re-trigger this job. Ah. Alright. Re-triggers. Done. So I wonder if it'll pass. We'll see. But in the meantime, we have to figure out this single process case failure. And I've simplified it to, like, I've taken this one test that was failing. I've kind of like stripped out a bunch of stuff. And if I run it, I can reproduce the failure locally. So it switches to like about preferences, and then we just like wait forever. And that's the problem, because if you look inside the test failure, we like have this timeout and we're waiting for this on DOM content loaded. And this is all like the change I made was inside this script, which runs inside content, this frame script. And all its job is to like load a page and then tell the parent when it's loaded after it sees the DOM content loaded event. But I needed to like account for the about blank showing up in the multi-process case, because sometimes whenever you ask the content to load a thing, when you create a browser, it will have this like initial about blank, and sometimes that load event that will cause DOM content loaded to fire early, and you can't have that happen, because then the page will continue, like the marionette test will continue running thinking that the page is loaded when in fact the page is still being loaded, and it might try and like interact with the page and do things, and that will break. So we really need to make sure that the page is loaded. So I added some stuff with this like load listener and like a bunch of fancy business, and it's breaking in the non-e2nes case. So why? Let's add some logging. We'll start there. Requested to load URL, and then I'm going to print out the URL that we are being asked to load, and then dump saw state change for loaded URL. Dump saw load, and then here we're going to say dump saw DOM content loaded, correct frame, saw load. I could use template strings here, but I don't know, I just didn't. Loaded non about blank, and that's a big line. And now I'm going to run this, and the information I care about is going to be put in the Gecko log. So hopefully, will we see it here? Okay. Saw state change for loaded. Oh, because whenever we might get redirected to this file. Loaded URL. Requested to load about preferences. So in the about redirector case, sorry, SI about redirector. What do we want to do in that case? That's NSI about module. Is there a way of like checking? NSI about module. I don't know if this is gonna work. On state start. We were about redirected. Well, like a cheap way of doing it would be like if requested URL starts with about, then saw load equals true, else add the progress listener. And then when we remove progress listeners, will it fail if it wasn't added before? Turn false, so it'll throw if it can't remove it. Try. Catch. Okay. Will that work? That does work. It's not a great solution though. It's kind of a crappy solution. How do we detect an about redirect? I don't think we do. So the about protocol handler deals with it. So when we create the URI, about is safe. Safe to link for untrusted content. New channel. Then standard return case. We call new channel. Safe for untrusted content. Writable bag. Oh, get base URI. Property. About URI. Is there a way we can get like, so the request URI spec in this case is hang on. Get rid of this. We'll go back to where we were. Look at the problem again. So the saw state change. We were requested to load this, and then we saw a state change because, okay. Now whenever we load something like about preferences, the document URI, document URI is about preferences, but like the location.ref is also about preferences. Selected browser, current URI.spec. So everything outside says saw load. And it's the problem that's here, the actual hitting of the network, the loading listener. Whenever you load an about page, the load listener sees the like actual URI you're loading and not the fake URI. Unless we do do we do anything tricky with the channel? like that's about module. Let's look at a JavaScript example of an about module. JavaScript example of an about module. Sure, about. No, not what I meant. .js. Sure. Get the channel. Module info. The URI becomes like the Chrome URI. So we create, and the actual requested URI, what do we do with it? We set the original URI on the channel. Aha! Aha! Load your request is that loaded URL let is requested URL equal loaded URL equals requested URL, or loaded URL or request. So we've NSI channel. How am I going to do this? If not, request dot instance of CISI channel bailout. Original URI. Do we do that in the other cases, like about preferences? NS about redirector.cpp. The browser. Original. Yeah, I think we do. This is good. I think we can use this. Okay. Is document is that is loaded URL equals request URI.spec. Let is requested URL equal loaded URL equals requested URL, or request dot, what was it, original URL? URI, original URI. Let loaded URL let original URL equals request dot original URI dot spec. Oh man, all this mixing of URL and URI. I should just like fix that. Alright, is requested URL equals loaded URL equals requested URL, or loaded URL equals original, or original URL equals requested URL. And then if that and is requested URL, then we saw the load. Let's try that, and then we get rid of this garbage. I did not like that approach, so I'm glad we don't have to do it. Alright, let's try it. Yes! Alright, let's disable, let's try the E10S case. Good, 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 good. Now, there were a couple of other tests I remember. Modal dialogues. That was the one that was failing before in the E10S case with my patch. So let's try it now. Woo! A lot of testing. This is good. Booyah! That's what I like to see. Green, green, green.
That's right. Hi-oh!
Oh, yeah.
This is good. All right. I feel confident now. A lot more confident than I did whenever I saw these oranges show up. That was a depressing moment because I thought for sure I'd fixed it. So let's take a look at some of these other failures. Like I'll run. So it was test about pages was totally busted. Test navigation. Let's try that. Test navigation. We'll try it with E10S enabled. Oh, I should also try this dialogue. Test modal dialogues. I should also disable E10S. All right. That's exactly what I wanted to see. And then I'm going to do this test navigation one. This one might be a problem. I guess we have to handle the case where we go to a non-existent URL. Okay, that's good. Good to have noticed that. Non-existent URL. Should have thrown a marionette exception. Should not be a timeout. Should be an error loading page. Oh, hold on a second. Marionette exception. Thrown a marionette exception. Should not be a timeout exception. Should be a marionette exception. Okay. Unknown error. So let's put our logging back. Shoot. Saw on state change. Loaded URL is. And original URL is. Dump. Whoops. Oh, hang on. We're gonna need the gecko log. Also, no. Stop it. Stop it. A lot of these tests I don't need to run. I just need to run this one, this non-existent one. So I'm going to get rid of all of these other tests. Just going to disable them all by getting rid of them. Gecko log dash, and that puts the gecko log, the dump stuff, into the console. Requested to load this. We see DOM content loaded. We never actually see a state change. Dump saw on state change. We never see the on state change. This address wasn't understood. What is that? This address. Unknown protocol. Unknown protocol. Net error. So if we see on DOM content loaded, if it's a network error, then we should just go for it. How do we find out if it's a network error? Network error page. So if I go to like hamster or whatever, hamster // test. Nope, I'm actually looking for something. I don't. I'm not trying to search for it. Come on. This protocol doesn't exist. Need to like get rid of keyword enabled. Okay. Now what is my address? Location.ref is hamsters. Document URI. Is this about net error thing? Okay. If saw load if occur container.frame, what do we currently do? Requested URL. Is that right? What does Marionette currently do? Listener.js. Marionette function get. It's just any. It's just any. So what was I doing before? Marionette listener. I was checking to see if the frame location is the requested URL. Okay. It likes it. Okay, so let's put all the tests back. Get rid of the gecko log. Alright, now we disable E10S. Try it there. Okay, now how about the old ones that we were worried about? Modal dialogues, for example. Alright, now let's disable E10S. And if I'm going to run that other test one more time, then I'm going to push to try, and then, well, hang on, I might clean it up a little bit, run a test one more time, and then push to try, because I feel like there's a little cleanup we can do in here. Alright, pretty happy about that, and then the last one was about pages. And disable E10S. Alright, so what's the cleanup I'm talking about? So, for one thing, I'm going to get rid of the my logging again. Is requested URL. Saw load is true. That actually should. So I'd gotten rid of the removal. Just in case our timer function fires just before. Well, it couldn't. It couldn't. And on DOM content loaded, it can't. So this should. It shouldn't be possible for the. No, I think we should just do that. Shouldn't be possible. Okay, we can clean that up. So look at the original URL, because the loaded URL might, because for pages the loaded URL is what the about page resolves to and is not the one that was requested. If the page we're at fired DOM content loaded and happens to be the one we asked to load and appears to be the one we asked to load, then we definitely saw the load occur. We need this because for error pages, like about net error for non-existent or for unsupported protocols, we don't end opening a channel that our web progress listener can monitor. So this is a very, I think, resilient loading function. It's covering a lot of cases. Okay, so that's nice and clean now. Where am I? Okay, I'm gonna commit amend. Gonna, ooh, failed a lint test about pages. I shouldn't have even changed that about pages. HG uncommit that. Let's take a look at our patch. Should all be inside listener. Yeah, there we go. Alright, let's push this to try. And then I think I'm gonna call it a day for this episode. Made some progress, you know, like we're gonna push this to try. Push to try. Gonna push that to try. Hopefully that'll all turn green. I'll fold that into my patches, or I'll just throw it on top of the stack and have someone from the Marionette team look at it. For the TS Paint thing, I gotta figure that one out. I'll do that. That shouldn't be too big a deal. Hopefully I can reproduce it locally. And then, let's see. What do I want to do after that? Then hopefully I can, I'll have all the stuff done that, like if I can get that landed, I can land my make initial browser be remote patch. Finally. It looks like I'm going to make the 50 cutoff, which I'm happy about. Assuming things don't go horribly wrong. Fingers crossed. Alright, switching back to this. Thank you so much for watching episode 64 of The Joy of Coding. Hang on, hold on a second. Let me go back to my screen. I forgot. I want to give a shout out. I want to give a shout out to a fellow named Danny O'Brien. So I work with someone named Lizard. That's her screen name. But her partner has this live coding channel called Code Therapy. I highly recommend you check it out. You can watch Danny O'Brien work through a bunch of like problems just like what I'm doing, just working through programming issues and, you know, doing lots of things. I think he's learning Elm, and he's like, I think he's spending time learning Elm, if I understand correctly. And that's awesome. And you should totally check it out.
Tehran. I'm now streaming live and I'm recording, so I'll start briefly again to explain what I'm doing here.
So he's also got the green screen action going on. It's great. You should totally check it out. If Elm is a thing you like, I highly recommend it. So shout out to Danny O'Brien. Thanks for doing your live streaming. Code Therapy is awesome. Keep up the good work. And a final request: if this episode, let me know how you felt about it. There's this link in the agenda to rate the episode. That's also in the video description, or additional links. And if you're on YouTube, yeah, it's in the description where the agenda is. And let me know what you thought, and that way I can like help to tune these episodes and make them better. That's all I want to talk about today. Thank you so much for watching episode 64 of The Joy of Coding. I'm just gonna cap it there. Take care. Bye-bye.
The joy of coding.
See ya.